Okay, we're supposed to put these vocabulary items into the boxes. So number one, this is a quadratic in standard form. And again, you can use these on the quizzes that's coming up. You can use these on the test or quiz, any of them, except for the finals. And this is, let's see, this would be a standard form of a quadratic function. Let's see, a line that divides a parabola into two mirror images. That's going to be your axis of symmetry. Number three is just a picture of a diseased parabola or parabola. Number six, y equals x squared. Well, that's the parent function. Parent. Okay. Parent quadratic function. It's your partner in crime. Number five, the y value of the vertex when the parabola opens up. Well, let's sketch a parabola or parabola opening up. So here's our vertex. What's going to be the y coordinate value? Our vertex. The y coordinate is going to be its, that's right, minimum. Since we're doing minimum value, let's look at number 7. If my parabola opens downward, here's my vertex. What's going to be my y value here? You can do this, kids. I know you can. Maximum value. There you go. Maximum value. Let's go back up to number 4. What's hk in the vertex form y equals a times the quantity x minus h squared plus k? Got that right? That is the vertex. Hk is a vertex in vertex form. Well, if that's the vertex, what's y equals a times the quantity x minus h squared plus k? That's right, vertex form. And the last one, what is a shift of the graph, horizontal or vertically? Translation. Can't spell today. Why should today be any different? Those are some pretty shoes there, Bryce. You can use these notes on the next quiz. Okay. Point 2. I'll give you 30 seconds. Go. Go. 25. 20. 15. 10. 5. Okay, that's it. Next page. Okay, a couple of things here. We should do some notes to help you out in the next quiz, right? Let's see. Let's talk about standard form of a quadratic, which is y equals ax squared plus bx plus c, where a does not equal 0. What would happen if a equals 0? We'd have a bunch of zeros. Be a linear equation, wouldn't it? Yes, Mr. D, it would. Okay, so let's talk a little bit about what a did for us. If a is negative, what happens? That's correct, kids. It opens downward. Or in other words, flips. How about if a is a fraction between 0 and 1? What happens to my parabola? That's right, kids. It's wider. What happens if a is greater than 1? Way to go, kids. It's narrower. The x coordinate. The x coordinate of the vertex. Are you ready, kids? Okay, the x coordinate of the vertex is negative b over 2a. How do I get the y coordinate? Plug it in. Okay, anything else about standard form here, or did I miss anything? When we were doing those, graphs manually, I was giving you many, many, many hints. Guys, wake up. I was giving you many hints that the y-intercept was that constant c at the end here. So the intercept was 0, comma, c. Nobody got it, though. Let's do some example problems so you have some example problems when you do the quiz on Thursday. Okay, which function is written in standard form? The first one or the second one? That's beautiful, kids. Which x coordinate is -5? First one. Which quadratic has an y-intercept of 2? Second one. Has to be in standard form and the last term. Which parabola opens downward? First one. Okay, let's talk a little bit about vertex form. We have y equals a times the quantity, a times x minus h squared plus k, where a does not equal 0. Because if a equals 0, what do we have? That's right, children. We have a linear equation. Okay, the A's could do everything that it did up in standard form, right? If A is negative, it's going to flip my graph or open downwards. If A is a fraction between 0 and 1, going to make my graph wider. If it's greater than 1, it's going to do what? That's right, kids. It's going to make it narrower. And vertex form. Our HK is indeed the vertex. What else? What else about vertex form? H moves it which way? That's right, left to right. The K is going to move it up or down. Anything else? Anything else you want to put on here for the quiz? Example problems? Which function is written in vertex form? 1 or 2? That's right, 1. Which quadratic has a vertex of -2, 4? Very good. Which parabola opens upward? Fantastic. Okay. Now, a lot of times in the very near future, you are going to be converting equations from one form to the other. The hardest thing is going to be converting it to general circle form. Okay, we're going to be using completing the square. Now, in number 8, we actually had a quiz on this, and we didn't do too good. We're converting this from standard form to vertex form. And the way we do that is we have A equals, what's my A equal? That's right, children, 1. What's my B equal? That's correct. It's -6. What's my C? Wonderful. All right. So I'm going to find my vertex. My vertex, or x coordinate of the vertex, right? Equals -b over 2a. So I have -6 over 2 times a, which is 1. So I have +6 over 2, which is 3. So right now I have a x coordinate of 3 for my vertex. What's my y coordinate? How do I find my y coordinate? Plug it back in. So y equals 3 squared minus 6 times 3 plus 12. 3 squared, 9. 6 times 3, 18, plus 12. Let's see, 9 plus 12 is 21, minus 18 is 3. Vertex is 3, 3. This is how review. Giving you notes for the quiz. All right, do I have everything for vertex form? Let's see, y equals a times quantity x minus h squared plus k. My a is 1. X minus my h, which is 3 squared plus k, which is 3. Here's my answer. Questions, comments, concerns? Do you have it? No? All right. Now, this whole time you guys have been asking me, what are we going to use this for? When are we ever going to use this in life? Never. Okay. Why did we have to learn this stuff? Why do we have to learn this stuff? Why are you teaching us this stuff? Well, no. Okay, so you're going to be become mathematical modelers, and you're going to use all that knowledge that you gain by that tedious little computations that you've been doing. And that's called quadratic models with a graphing calculator. All right, if you're a physics guru, you are ahead of the game here. Okay, we're going to look at the mathematical model of an object that is launched on Earth. It's important, on Earth. This one will be. Okay, so when an object is launched on Earth, we're going to use the model H. Quiet. Guys, quiet. When an object is launched, we're going to use the model H equals negative 16t squared plus, this is called V naught. When I was learning it, it was called V sub 0. So I will probably refer to this as V sub 0 times T plus H of 0, or if you have a new modern math teacher, they will say H naught. First thing we're going to do is define these variables. Okay, this H stands for, what do you think? Height. How about the T? What do you think T stands for? Time. There you go, kids. Time. Now our V sub 0, our V naught. Velocity. It's not the velocity, it's the initial velocity. Okay, what do you think H of 0? Guys, shut up. Initial height. Good, because we're going to spend the next couple 3 days on this, and it's going to be on your next quiz. Okay, what do you think the negative 16 coefficient is? It's a constant, kind of like E, Einstein's theory, E equals mc squared. It's a constant. We're launching a rocket. It's fighting what? Gravity. Okay, this negative 16 is actually measured in feet per second. And that's what the velocity of gravity is. Okay. Now, we, meaning the U.S., are the only people in the world that uses Blake. Blake! That's inappropriate.
What's inappropriate?
It's okay if you choose not to learn, but it's not okay if you keep other students from learning. Got it?
Yes.
All right. In the US, we are the only ones that use the standard system. Everybody else in the world uses metric system. Good. They measure gravity in meters per second, and the conversion of negative 19 to meters is going to be negative 9.8. Okay, so you're going to have to be careful and read the problem carefully to make sure that it says feet or meters or whatnot. Did you lose your glasses? I have a pair. I don't know. I do have a pair of glasses here that. Okay. All right, are you ready, kids? Here we go. A rocket is launched directly upward at 45 feet per second. What is that? 45 feet per second. What do you think it is? Look at our equation here. What do you think that is? Velocity, our initial velocity, right? From a platform 70 feet high. What's that? Height, the initial height. Okay? Because the initial height is different than the overall height. Pardon me? Well, it's because it's launched. That's when it starts. Okay? You're launching this rocket, and it's starting. That's your initial velocity. From a platform 70 feet high. So it's already 70 feet high. Starting. That's initial. And it's given by the equation S of t equals negative 16 times t squared plus 45t plus 70. Now, I don't know what this is trying to do here. What is S of t business? I don't know. Let's answer these. What is the initial velocity of the object when it is initially launched? 45 feet per second. And we said that. That's our V now. V is 0. Now, what's going to be this object's maximum height? Explain what point that's going to be in English. It's not a value because we haven't plugged anything in. Well, hey, let's figure this out. Here's my y-axis. Here's my x-axis. Okay. Where are we starting? 70 feet high, right? So my y-axis is actually what? My height. So I'm starting there, it's going to launch, and then it's going to come down and hit the ground. It's not going to go to below the ground because what's going to happen? It'll go straight to hell, remember? Can't go underneath. All right, so what do you think our x-axis is? If this is the height, this is our height, can only be one of two things. Either time, right? In this case, it's time. So our x-axis is time. So it's asking, what will be the object's maximum height? Well, that point's going to be here, right? Also known as the vertex, or our maximum. Which coordinate is going to give us the height? The y or the x? The y. So the maximum height is going to be the y coordinate of the vertex. Okay, which is actually our h, because we're doing h and t. All right, C, how many seconds, and I'm assuming that's why it's S of t, how many seconds have elapsed when this height will be reached? So right there, we want to know how many seconds that is. It's going to be our x coordinate of the vertex, right? Okay. Got it? Any questions? Comments? Concerns? All right. So they want to know what the height is. They want to know what h or y, right? It's the same thing. They want to know what h is given these times. Now, they're choosing these times, so that's our x values, right? Now we could go back and plug one of these in for time, each one, but what's going to be easier? That's right, kids. Your calculators. Okay, I'm going to go to my y equals, put in our equation, which is s of t equals negative 16. We don't have a t. We're going to have to use x squared plus 45. Oh, they give us a number for x. Sorry. They want us to put in 1. Okay, so negative 16 times 1 squared plus 45 times 1 plus 70. No, that's not what I want to do. Sorry, my fault. I want a number, so I'm just going to compute this. So just go back to your regular calculator screen, put in negative 16, 1 squared plus 45 times 1 plus 70 gives me 99. Okay, then they want it for 2 seconds. I'm going to go back and capture. On mine, I can copy and paste. I don't know if you can do it on here. I'm going to put in 2, hit enter, and I get 96. And then I'm going to go back, capture it, put in 3 for my x, or t, and I get 61. So what's happening here? It's decreasing, or in other words, it's already past its height. Okay, so we're on the downside of this. Now, next thing, they want to know its rate of change. What is rate of change? Anybody remember? All that is our slope. That's our slope, rate of change. Okay. Anybody remember the rate slope formula? Yep, y2 minus y1 over x2 minus x1. If you had a highly qualified math teacher, they told you that that was the change of y over the change of x. And those symbols are delta. That's delta y over delta x. And actually what we're looking for is delta h over delta t. So kids are so much older and braver and mathematically up there level, you're going to use delta symbols, right? Okay. Yes, sir. It just means the change of h over the change of t. Okay. The change of h. See, I've got 61 minus 99 over 3 minus 1. 61 minus 99, negative 38 over 2. And what does this come out to be? Negative 19 feet per second. Now, can we go a negative 19 feet fast? No. It's negative 19 because we're on the downside of the parabola. But you can't go a negative 19 speed velocity, right? Got all that? Can you try one on your own? Are you ready, kids? Aye, Captain. All right, let's try number 2. An object is dropped from the roof of a 120-foot building. How long must it fall to hit the ground? Can we draw a picture first? Can we? My height. Here's my time. Correctamundo? All right, so I'm going to start where? 120 feet. This is my initial height, my h of 0. 120 feet. Okay, so it's dropped. Splat. Okay. We dropped it. Again, this is my h, this is my time. Now it says, how long must it fall to hit the ground? So we're looking for this time, right? Well, let's think about this for a sec. This point here, what do we call this point? Where you sleep? The point where you sleep? X-intercept. This is our x-intercept, right? So if we find that x-intercept of our parabola, we know how long it went, correct? Way to go, kids. Okay. Huh? It's not Chuck E. Cheese, man. What's wrong with you? SpongeBob. God. You don't even know your SpongeBob's and your Chuck E. Cheeses. All All right, so we got the sketch. Now, we have to do gravity, right? So we want to find the height. We want to find the seconds, so we're going to do a function. It should be an S, actually. Okay, so we have negative 16 t squared. What's our initial velocity right here? How fast is this thing dropping at 120 feet? Yeah, that's gravity. There's nothing I can do about it. That's gravity constant. Because gravity is negative 15 feet per second. This pen is going negative 16 feet per second. It's constant in physics. Okay, so I have negative 16 t squared. Remember, I'm trying to get that v sub o times t plus my h of 0, right? There's nothing we can do about the negative 16t squared. Nothing we can do about the time. We're trying to figure that out. But what is my initial velocity at 120 feet? How fast is this dropping at 120 feet? It's not. Okay? It's 0. Okay, that's my starting velocity, is 0. Now, my initial height again is what? 120. I'm going to simplify this. and now all I have to do is find the x-intercept. Easy peasy, right? I'm going to use my calculator. It's not as easy as I'm going to make it out to be. Okay. My last class, I kind of really, they didn't understand the thing I was saying. Now, what's my y-intercept? 120. So my y-intercept is 0, 120, which means in my calculator, if you go to your window here, we have these x-mins, x-max, y-mins, y-max. It says my y-max or my y-intercept max is 10. What's going to happen if I put this in there and it's supposed to be 120, but I got 10 in there? You're going to get this really blown up picture of this parabola. I will show you. I have negative 16 t squared, we have to use x, plus 120. And when I go to graph this, I get this blown up picture of the graph. Now, you can do a couple of things here. You could zoom out, zoom out, zoom out, zoom out until your finger turns red. I'm looking for this point. You could try to calculate that, go to second, trace. We're trying to get to 0. But I have no idea where my cursor is because it's so blown up. It could be up here, it could be down here, be over here. So I'm going to fix my window. And I'm going to put that y max. I want to see my whole parabola. So I'm going to put 130 in there for my y max. Okay. I really don't need to see below Earth's line or the other side, but that doesn't exist. So I'm going to put this at -1. Let's see. I'm assuming that this is going to be pretty fast. If I look at my graph,